welcome to Physics Academy. So we will be learning about first part of the forces. So the whole topic of forces, there will be mainly 4 parts covered, where the first part will be the introduction of what are forces. Alright, and the second part will be on how do we do resultant forces, how do we do resultant of a few forces, and those resultant forces will be divided into same direction forces, opposite direction forces, and also different direction forces. How can we find the result of those forces? Right, so without waiting further, let's go into forces. So what are forces? So a force is basically a simple idea of a push or a pull. So by definition, we can say that a force is basically a push which is experienced by an object, or a pull which is experienced by the object. So we know that whenever we are moving a thing on the table, we are either pushing it or pulling it. So the push and pull, the action is showing that we are actually exerting a force onto the object. So when we have an object falling, it's the same thing. There is a force that is acting onto the object that makes it fall downwards, that is pulling it downwards. If you want to make a ball move upwards, you need to push the ball so that the ball can move upwards. So as simple as that, a force is basically an experience of a push or a pull. Right? So there are generally 2 types of forces, where we call it contact forces and also another type which is called as non-contact forces. So contact forces are the type of forces which requires object to be touching each other, or the force that is acting onto the object requires it to be touching the object. So object must be in contact with the source of the force, source of the push or a pull. So what is pushing it or what is pulling it? So if it is a string, the string must be attached to the object so that the string will be able to pull the object. If we are the person who is pulling the string, so we must be touching the string so that we can pull it. If it is a spring, then we will be extending or compressing the spring. That means we will still need to be touching the spring. So example of contact forces, it can be something, for example, it can be friction. Friction is as if like whenever we are rubbing our hands against each other, we can feel that it is having some kind of roughness. So the roughness of a surface is related to the friction. You can also say as our idea, sorry about that, of the tension, where the string becoming tighter or looser, that is an idea of tension in the spring. Right? They can also have a contact force such as maybe air resistance or water resistance, where the air molecules must be rubbing against a surface so that they can provide a certain form of resistance. Okay, the second form of a force, second type of a force, is also known as a non-contact forces. Non-contact forces. So that means for this case, for the force to be acting, it need not to be in contact with the object. Not touching the source of the object, of the force, sorry. Not touching anything. So example of these forces, example of the object falling earlier that I gave, which is due to the gravitational force. Bear in mind that gravity is not a force, right? Gravity is how much an object is being accelerated downwards by the gravitational force. So that's why when you relate to the gravitational force, we don't say that the force is known as gravity. We say it is known as gravitational force. It can also be magnetic force, which is due to some magnets. We have experience in our life, we use magnets to move objects without touching them. So magnetic force is an example of a non-contact force. We also can use electric force, whereby in the electricity chapter later on, you will be learning about when we have two objects with the same charge, negative or positive. That means if they are of the same charge, positive and positive, or negative and negative, they will repel each other. If they are of the different charges, negative and positive, they will pull each other. So there will be an attractive or repulsive force between these forces. So we can see also the gravitational force between the Earth and the Moon, which can cause some sort of high tide and low tides. So those are all due to non-contact forces. Alright, so other than those, you also need to know all the names of the forces that are involved. So for example, the basic force that we know will be friction due to surface roughness. You also need to know the upthrust, or also known as the buoyant force, which is due to the floating sensation of an object when you put it into a liquid or into a gas, where objects can actually float or can actually float in liquids. So that is because of the liquid is also pushing the object up. Right? Other than that, you also need to know air resistance. You also need to know water resistance. Right? You also will need to know about gravitational force, where it is due to some objects experiencing some form of pull or push by the planets. Other than that, you will also need to know magnetic forces, electric forces when you come to the specific chapters later on. So the most common forces that you will be encountering now for the early part of physics, these will be the forces. Alright, so since we know that forces are acting onto an object, so it can cause some changes to the object. So what are those changes? That means what are the effects of forces onto the object? When you have a force acting on an object, what can the force do? So for example, let's say you have an object which was initially just resting on the bench. So the object is not moving, it is just resting. So after a while, you feel that you want to move the object to a different place. So what will you do? You will basically add on a force onto it, either by pushing it, or by pulling it, or by carrying it up. So the force can be acting in multiple directions. You can either act in the forward direction, you can act it into the backward direction, upward direction, forward direction, or downward direction. But we know that the downward direction for this case, because there is a bench, it doesn't make sense to push it downwards because there is a bench blocking it. So therefore we can just omit the downward force. So we can have forces acting on this object in multiple directions. So what change that you will see on the object? The change that can happen. Okay, the change that can be caused by the force, or the effect of a force onto the object, it will be the change in position. Or firstly, what we will see is the change in the speed. Initially, it was not moving, then it starts to move. So because there is a force acting, therefore the speed changes from not moving becoming moving. Right? If the object, basically, let's say if it is a rubber object or something, right? You try to press it or you try to squeeze it. What will happen? The shape will change. So it will cause change in shape. Or if an object is already moving and you want it to move in a different direction, you have to push it or pull it into a different direction. So that means it can also cause a change in direction. So that means a force or a resultant force can cause these three changes. Please remember that the mass of the object cannot be changed by the force, by any force acting. Okay, mass cannot be changed by an object. The mass will only change unless you break the object into two different parts, or unless you cut off one part of the object. That means you are removing a certain number of atoms from the object. That will cause the change in mass. But in idea of forces, usually we do not have the change in the size of the object or the number of atoms of an object. Alright, going on further, since we have the forces which are acting in multiple directions, so how can we represent them in terms of drawing? So if we want to draw and we want to know the value of the forces. So all forces, we know that every physical quantity that we have in physics must have a magnitude and also a unit. So magnitude means the numerical value of it. So for our case here, our force. Right, for our case here, our force. So a force is always read in terms of Newton, where it is to acknowledge the idea which was found by the scientist. So Newton will be the unit of the force, and what would be the value of the force. So maybe let's say we will use an example of 10 Newton. So all forces that we act onto an object must have a certain amount of it, amount of force. So the amount of force that we are concerned now is for an example of 10 Newton. Right? So how can we actually draw this, realize this as a thing that we need to use it to calculate something? Right? We can do the simple mathematics by adding or subtracting the numbers. But sometimes we need to know based on the vectors, because a force is a vector quantity. We have seen this in our previous video. So vector quantity. So a vector quantity must have both magnitude and direction. So in our case, our magnitude is 10 Newton. And the direction we don't know yet. Let us set one direction. So let's say for our case, we want the force to be acting to the right, and the value is 10 Newton. So we have a 10 Newton force to the right. So we can represent this sentence with a vector. So we know that a vector is always represented by a line and an arrow. So we will, first of all, since it includes drawing, we need to choose a scale first. So choosing a scale, because drawing requires you to know how long you're supposed to draw the line. Without a scale, you will not know how long the line would be. So therefore, choose a scale. So 1 centimeters represents, let's say, 2 Newton of force. So that would mean that if we want to draw a 10 Newton force, we will have to draw a line which is 5 centimeters in length. A straight line, 5 centimeters in length, and there should be an arrow which is pointing to the right, because our force is 10 Newton to the right. The length of this line from here all the way to here, the end till end, it should be 5 centimeters in length. And the direction must be pointing to the right. If you are to reverse the direction, Let's say you would like to increase the challenge and you want to try out 10 Newton force to the left. So the same thing you have to do, the drawing will be the same, where you have to draw a straight line and now pointing to the left, and the length of this straight line must also be 5 centimeters based on the scale that we have chosen. If you would like to increase more difficulty level, let's say number 3, you want to have a 10 Newton force acting 30 degrees above the horizontal. So that would mean that you need to have a horizontal line first as a reference, and you have a 10 Newton force, which will be a 5 centimeters line in our case, pointing 30 degrees from the horizontal bench. It can be a bench, it can be a horizontal surface, anything as a reference. And the length of this line should be still 5 centimeters in length. So by knowing all these main ideas about forces, first of all, the definition about a push and a pull, and the push and the pull experience can be due to some form of contact forces, as if like you are pushing the box, you need to be holding or touching the box, or you can make a ball fall from a tall building. That means the gravitational force will be pulling it down. It's a pull force, right? And as the ball is falling down, you will be experiencing the air, which the air will be producing or providing the air resistance to the ball. Or when you are driving on the road, there will be friction between your tires and the road surface because the road surface is rough. And also as your car is moving through the air will also be providing air resistance, right? So, and we know that when we have forces acting, let's say if there is a lot of friction acting on your car will not be able to move that fast. So that means it can cause a change in speed. A force can cause a change in speed. If you have a rubber ball and you want to change the shape of the rubber ball, you can also squeeze it. You can actually twist it. So that means a force can cause a change in shape. And also if your car, you are driving at a junction and you need to turn into a right junction or a left junction, you need to exert a force onto your steering wheel so that your car will be pushed or pulled to the other side, either to the right or to the left. That means the 3 effects of forces, bearing in mind that mass cannot be changed. And also, how can we realize or how can we visualize visualize forces? It means that in terms of vectors. That means by drawing lines and arrows, where the length of the line will represent the magnitude of the force and the arrow represents the direction. So I hope these lessons have helped you understanding forces. I'll see you guys again in our next video, which will be on a simple idea of how can you add vectors or add forces, or how can you find a simple resultant force. Alright, see you guys in the next video.